Okay, welcome back. When we left off last time, I said we would stop right here and pick up with these energy conversions next time. Before we take a look at conversions of energy, I want to take a look at this review of the idea of conservation of energy.
The law of conservation of energy states that energy cannot be created or destroyed, but only converted from one form to another. Some energy may be lost to friction and air resistance, but the overall amount of energy stays the same.
Now, when we say lost to friction or air resistance, it's not really lost. I mean, the friction produces heat and wear, so the energy goes into that. And when it goes into the air resistance, the air molecules move and they pick up energy. So it's not really lost, it's changed into those other forms.
Most energy conversions are not very efficient. There's always a loss of useful or usable energy. A perfect energy conversion is impossible because this means that all the energy in the conversion would be turned to useful work. For example, a car is about 22% efficient, as much of the energy changes to heat and is used to overcome friction and inertia. The human body uses food as its fuel source. The chemical energy is converted to energy to help us move, breathe, think, and carry on all the other important functions that keep us alive. However, the human body is not very efficient, and during this conversion, 95% of this chemical energy is converted to heat. Think of the last time you were very active and produced a lot of heat as a result. Remember, energy cannot be created or destroyed as it is converted from one form to another. Here is an example. Look at this setup of 5 metal balls hanging from strings of the same length. The balls are all exactly the same. What do you think will happen if we lift one ball and then release it? If you thought that only one ball from the end would pop out, you're correct. Notice that it goes up almost as high as the first ball and then swings back, hitting the group and sending the first ball flying again. Each time, the height that the 2 balls reach is lower until, eventually, they would stop this movement. This back and forth movement doesn't continue forever because energy is being changed to heat due to friction and air resistance. Now, let's change things a bit. This time, we will release 2 balls from one side. What do you think will happen? Pause the program and make your prediction. As you can see, 2 balls from the other side bounce out. Scientists call this the law of conservation of energy, which simply means energy is neither created nor destroyed. It is transferred or changed from one form to another. Let's try another setup. This time, we will release 3 balls from one side. There are only 2 balls left hanging straight down. What do you think will happen this time?
So what they're trying to show us is that the energy is conserved. No matter what energy, like as he raised these up, he added potential energy to them. So when he raises them to the highest point and they're motionless, they have all potential energy. As he lets go and they begin to move, in the middle part, they have mechanical energy because they still have potential to go lower, but they're also moving, so they have kinetic energy. But their total energy stays the same. So we should make the prediction that the amount of energy in 3 balls will be conserved.
Pause the program and make your prediction. Were you surprised by what happened? One of the balls joins the 2 so that the amount of kinetic energy is equal. Now let's change things by releasing 1 ball from each side at the same time. Pause the program and make your prediction. Did you expect the balls to bounce back out? As long as the strings don't get tangled, you could do this with different numbers of balls. When we lift a ball to a certain point before dropping it, we have given it potential energy. Someone has used his or her muscles against gravity to lift the ball to a certain height. When the ball is released, it begins to swing down. The potential or stored energy is changing to kinetic energy, or energy of motion. When the ball hits the group of balls, the energy is transferred or moved
Okay. At this highest point right here, it has, and it's motionless for that one instant where it went up, and it has to stop for an instant and turn around. It's all potential right here. In the middle, at any point,
from one ball to the next until the ball on the end is pushed into.
right here, it's in the middle. It still has the potential to go lower. So it still has some potential energy, but it's moving, so it has kinetic energy. Here where it has both, we say that this is the mechanical energy is the total of both.
The air against gravity. This ball reaches a certain height and stops. At that point, it has potential energy. Then it begins to swing down, which means its potential energy is changing to kinetic energy. Look at this amusement park ride and think about how it might be another example of potential energy changing to kinetic energy, and then kinetic energy changing to potential energy, and so on and so on. How much kinetic energy an object has depends on two things: how much mass the object has and how fast the object is moving. Forms of energy are all around us.
So let's think about energy conversions in our body. Human beings store energy from food. Okay, this is why we got to eat. Without the energy that came from food, we would, we just stop existing. So the energy that's in the food came from the sun. This is why we call plants the producers, because they produce food. And they're the organisms on the planet that can take energy from the sun, okay, and they absorb it in their leaves, okay, and as they absorb it in their leaves, they store it as chemical potential energy in the bonds that form between the atoms when they bond them in, and they make the glucose, and then that's when they're storing chemical potential energy. So it's energy from the sun that's being stored in those molecules. And when we eat those molecules and break them apart, that energy is released, and it's released into us. And this is what gives us the energy to move around, to talk, to think, to stay warm, to run, to go outside and play. Okay, so the energy in food is chemical potential energy. We change this energy into mechanical energy when we move. Remember, we're a system of parts. So your heart beating, your muscles moving, everything that's happening inside of you, you're a system. So when you move around, you have that mechanical energy. We also change it into some thermal energy to stay warm. And then, of course, when I'm speaking right now and explaining this to you, some of it is converted into sound energy when we speak. Let's think about energy conversions in cars. Okay, where does the car get its energy? Well, it gets its energy from chemical potential energy in gasoline. Okay, and again, that chemical potential energy came from the sun, and it was stored during photosynthesis in ancient plants and animals. And we're going to talk a little bit more about fossil fuels later in this unit, but that energy that came from the sun has been stored in those chemical bonds, just like energy is stored in food, okay? And it's been sitting there in the ground for millions of years, waiting for us to burn it and release it. And it changes into mechanical energy when the car moves. Again, remember the car is a system of parts. And thermal energy, when heat's given off from the engine, as the gasoline is burned, thermal energy is released. That's why you have a radiator to cool the engine. Also, from the heat and the parts of the car rubbing together, it produces more heat and thermal energy. And it also changes into sound when we hear the car move and the engine and the sounds that it makes. Okay, conversions in nuclear power. Okay, nuclear energy is energy that's stored in the nucleus. And when we split atoms, we change the stored energy into thermal and into a form of radiant energy, okay, during nuclear fission and fusion. So when we split atoms at a nuclear power plant, okay, the atoms split and they release a lot of thermal energy, which is a form of radiant energy that and then that energy, we're going to talk about the conversions that go on in a power plant, or when the sun fuses atoms together. So it takes the two smallest atoms like hydrogen, it fuses them together into one new atom, which is helium. When that process happens, It releases a lot of heat and energy, and that's why we get, the sun sends energy to the earth that can be stored in the chemical potential energy of food and fuels. Okay, generators that we use normally to make power. Okay, so or a home generator is the energy starts off as chemical energy in gasoline or other fossil fuels that we burn. Okay, sometimes it could be nuclear energy or gravitational potential energy and hydraulic. So the energy that's stored behind the water in a dam is gravitational potential energy, and as it goes down and it pushes through the dam, it releases that potential energy to turn the turbines in the dam and change it into electrical energy. Okay, and then it converts it into mechanical energy by spinning a turbine, and we're going to talk a little bit more about that in this unit. And then the spinning turbine converts to electrical energy to power your home. And then some of the energy in everything that we build is always converted to friction or used up by friction, you can think of it. So friction converts some of the mechanical energy from a moving system into thermal energy, making heat, and some of it is also wear as the parts, as those micro welds rub on each other and things wear down. So it converts some of the energy of these systems into thermal energy and wear. So we say friction energy takes energy from motion, which is why it opposes motion or resists motion. Okay, we're going to take a look at this little slideshow I put together on energy conversions. Okay, so here we have this lamp, and it gets its energy from the electricity flowing through these wires, and then it turns that electricity into electromagnetic energy in the form of light. A hot water heater takes chemical energy from natural gas, it burns it, and it releases it into thermal energy into the water to make the hot water. The student converts chemical energy from the food into mechanical energy when they're moving around. Okay, so here we have energy coming from the sun that starts off as nuclear energy from nuclear fusion on the sun, where the hydrogen atoms are fusing together to make helium. It becomes electromagnetic energy as it travels through space. And when it hits the plant absorbs it through the process of photosynthesis and stores it as chemical potential energy in the glucose. If the plants died millions of years ago, those ancient remains of plants and animals decayed in the earth under heat and special conditions. That stored chemical energy is now stored in fossil fuels. The coal gets dug up from the ground and transported to the power plant, and the chemical energy that had originally come from the sun is released when it's burned in the plant, and it becomes thermal energy. That thermal energy is then used to heat water, which is used to, the steam goes past the turbine, and the turbine spins and turns it into mechanical energy. And that spinning mechanical energy turns the generator, where it becomes electrical energy. And then the electrical energy gets sent down the wires to this home, and it shows this lady cooking, and she's at the stove, and then the electrical energy becomes thermal energy again. So it's gone from nuclear to electromagnetic to chemical, from chemical to thermal, from thermal to mechanical, from mechanical to electrical, and then electrical back to thermal. So this energy has gone through all these transformations. We're going to stop here, and you are going to answer these questions on your own. And when we come back, we'll pick up here next time. I hope you're having a great day. We'll see you next time.